Hey everybody, so let me know if you can hear me well and see everything that's going on the screen. We'll start just in a second. So can you hear me well? So this time I managed to press the right button. Hopefully it will be okay with the stream. And please engage with the chat as well, because we're going to build step by step this Space Invaders game using just the console, basically very simple stuff. So last time I asked you to make sure that this spaceship cannot fly out of the boundaries, and today, this time, we're going to start looking at some of the object-oriented programming basics that could be useful. By the way, if you have any questions, then type in the chat or contact me later. So if you look at the code here, so let me just show you. So first of all, I have a template as well. So please, if you want to join the tutorial, then in the notes of this video, and I will drop here as well a link. So we have template that you can take as a code for this session. So the template is this one, and I'll just recap where we are. So if we run this inside the PyCharm, so the PyCharm is the environment that we are right now working on. So if I press here, run, by default, it just like draws something like this, where it's not really what I expected. So to change that, we go up here and press edit configuration. So every time you create a new file, I guess you need to go here and change to execution emulate terminal output console. I guess that's one of the small struggles around here, but otherwise it should be quite simple. So then if you run it again, then it stays at the same location. So now we have this small spaceship, and if I press the arrow buttons, so I can fly with this spaceship to the right side, and then I can fly downwards, and it's not going out of the boundaries. So if you take the template, you will see that maybe your code is a little bit different than mine that I asked you to do for the homework. So that's really great that some of the students that are joining this these sessions already did their homework. So if we check some of the solutions, so one solution is something like this. Not too bad. I mean, I like that you use the predefined variables. You don't hard code stuff, so that's really nice. You did not fix my bug of changing the height and weight here, because the rows are actually here and width is here, but it doesn't matter. You made it work in this way, so that's great. And also another person did this kind of implementation, a little bit more of hard coding and a little bit more of if statements. So also quite okay, not optimal, but okay. So and then the solution that I give you is something like this, just using mathematical functions of min and max. And then it's basically the same thing as I would do with if statements, but just using mathematical functions. So now I could write it in 2 lines. And if we would use NumPy or some mathematical library, we could even write this in shorter. So that's where we are. So let me know if the template is working for you. Is template code working for you and ready to continue? Plus, minus. If there is something not working, let me know. There might be also the thing about the windows. If you look up here, then you should change this for Windows to CLS. And in the template, again, I left it as for the Linux with the clear. It should be then CLS for the Windows. The command just for the console to clear the console. We could also write maybe next time I actually will do that, write this part as an if statement to check what kind of operating system you have, and then just use that part. By the way, maybe I should include that now. While I'm waiting for you to let me know if you're ready to work, I will quickly check the situation about just make a few changes. You don't need to do this now. I will include that in the next template. So if OS name, so if name, what would be the OS name for Windows? That is something that I'm not totally familiar now, because I usually work on Unix type systems. So Python OS name Windows, what would be interesting if you can just tell me what is there. NT, I guess. System, platform. Yeah, I think it's right. So if this is NT, then in that case the command should be CLS. So for operating systems, this is an operating system library. OS.name means the name of that operating system. In this case, for Windows, it's NT. And then this would be CLS. So now the code would work for Windows and for the Unix Mac-based systems. So I will make this part as well into Jamboard. Okay, so let me drop this into Jamboard. Okay, I see pluses in the chat, so that's great. So this part about making the code workable for the multiple operating systems, that's something you can change later. It's not right now super necessary. So let's go now back to the Jamboard, and let's talk about the other thing. So here I mentioned that we should work with Drawio. So please, either you could install Drawio, or you could just open it online, if I'm not mistaken. And this tool we will use for making these kinds of charts. So these charts will be something that will help us to illustrate and better understand the object-oriented programming, and then we will code it. And basically that's called Unified Modeling Language, one of the specific charts. There are different kind of charts and plots. So let's see. Yeah, so I should have done actually that before. Just a second. Let me quickly drop back here, and I will open the Drawio. Create new diagram. So okay, let me show you back. So when you open Drawio, you say create a new diagram, then we could just use blank diagram and number 3rd tutorial, space invaders UML. I don't know, like any place somewhere just to say. Okay, it's loading. Okay, so now, yeah, we have it here. And okay, so yeah, please open Drawio new project, blank template. We're gonna use it. So Drawio blank template, and what we're gonna look at is the basics of object-oriented programming, and we will implement them also properly in Python, hopefully. So object-oriented programming. So there are probably more things that are important, but some of the most basic things that usually people tell are encapsulation. So that just means that we will make that the variables of objects are not available just easily from outside world. So they have some kind of like inside state, like memory inside the object itself, the properties that are associated with the instance of object. So that will be the one thing. Then the other thing will be inheritance. So that will mean that we have some objects that will extend functionality. For example, we will have the elements on the screen that are non-movable, like walls, and then we have also aliens and spaceships and rockets, and they are all movable, but they all have the same positions, so we will use some of the code for the later ones. And then the last one will be polymorphism, which is not super easy to illustrate using PyCharm. It would be easier to illustrate using C++, but it's still also a very interesting property. I guess like C++, C# also might be easy to illustrate that. Basically any typed languages. But the idea is that you don't need to care about the actual object or the element type. It's just that we're going to work regardless of these types. So you will see that we'll go one by one through these properties and see how they are useful for the programming of this game. So let's go here, and if you go on the left side here, there's UML tab. And in UML tab, we should have something called class diagrams. So here we have class name, class 1, class 2. So just use, I guess, this class 1. So this we'll have. And we'll call first one, that the first thing that we're going to change in our code will be that we will make positions, not as some kind of arrays, but using some data types. So here will be the position 2D, and then here the way how to add these properties. So this is just a visual representation of your code, basically. So this is the class name, like the object name, and you will see in just in a second how to use it. And then here we have the kind of elements of properties and kind of variables that are, they called member variables, that are associated with this kind of object. So here what we do is press the right button and then duplicate, and then if I move this, it just gives a blue line and it kind of drops somewhere in. So this nicely like that. Then the plus sign means that this is a public variable, member variable, but this is not good. The public member variables should not be, almost never. So instead what we use is either private or protected. So let's think about private variables. So here will be the x position, and this will be integer, and then we will have minus y integer. By the way, again, just to say, what we're drawing here, this is just a visual representation of the code, how usually people do this to make the code more understandable and to communicate ideas and the way how it should work. And here, this is one of the most basic types of a diagram. So this is called class diagram. So you don't need to add the text here, but I will add just to give a little bit more detail. So class diagrams, UML class diagrams, unified modeling language. So it's actually like visual type of language in most cases. You could write it in some like Mermaid or other syntax. So this is what we have, and then up here we have the, I will just add some notes here. So you don't need to add these texts, they are just notes for myself. So there we'll have the class name. Class name is up here. Let me see, so this is class name. Then the next one is the member variables. So what it means here, the plus means the public variable. Plus is public, then minus is private or protected. Protected, we can talk about this a little bit later. It's not that important now. And then the last part is the member functions. functions, so they are only associated with this kind of object. They are not usable for other things in the code, and they should work with member variables and not with some other things. So let's see. So the one thing about encapsulation here, so let's add the process of encapsulation. So not letting access the some of the data from outside of the world. You will see that in a second. So this whole process is actually related with this diagram. So one, we have the x and y, these variables, but then we also need to have some way to change those variables, because as I say, if they are private, we cannot change them from outside world. So we use getters and setters. So they are called, there could be other functions as well, but you will see in a second also other functions. But for the encapsulation, you usually need something called getter and setter. Again, these things are maybe easier to explain in strongly typed languages and like C, C++, but also in Python, it's important to understand these concepts. So here what we have is that we'll have set y, and then there will be some kind of y variable with integer. So by the way, this, I mean x, so this x here that we pass to this function, this is not the same x as here up here. So this might be also useful to change the kind of naming here. So for Python, usually you add the this underscore here in front of those. So these will be private variables. So you set your x variable using this function, and sorry, you press duplicate like that, and then you get the x function like that, get the x value like that, and in this way we are protecting our variables from direct access. So you will see in a second that why it's useful. So let's see, then we will add set y, and then we will add, so the set y should be y integer like that. By the way, if you're not getting along with this diagram, don't worry. It's you could finish it up a little bit later, but let's see. So let's ask questions. So how? So is UML diagram ready? How much time do you need? So plus if it's ready, or let's say you say 5 minutes or more. If more, then we will just drop this into Jamboard, and you can return later to finish it. So I'm saving this as well. Well, probably if you have not used Drawio before, it might take a little bit longer for you. You just need to write. You just need to create this part, not other parts. So that's excellent. Christian is already finished, so that's great. So I will drop this into Jamboard as well. So this will be the encapsulation part. Let me illustrate that a little bit more. So what we are doing here, we are showing how to use encapsulation. And now let's implement the code of this kind of object. Okay. So to do this and to change our code to work with this kind of object, so let's go back to the template that I just shared, and we will change it a little bit. So this is the template. Okay, so we have height and width. Okay, so before we had just like some kind of list holding like x and y coordinates, but this is not really optimal because we cannot like very easily operate with this, copy, like we could copy pointers, but it's not understandable always that 0 means x and 1 means y, and it's a little bit confusing. So it's much better and cleaner to define the class here. So class position 2D, and here the next in the brackets we introduce what will be the object from which we will inherit this this object class. So, and by default Python offers this violet looking with small letter object. So that is like any kind of object, just anything that holds some of these properties. So now there is at the end the colon, that's very important. Then the tab, again, very important. Then the def, this is the function, but now the function lives inside that object. Then we have 2 underscore lines, and it gives, at least in the, let me show you. So in the PyCharm, it's very nice that it gives you also the autocomplete here, and it gives you that there should be initialization in it. Make sure that this is 2 lines, then init, not integer, but init, so that means the initialization. So that is like the constructor. So in constructor, we define some of the things that, so before actually defining some of the things, we should call the constructor of the, you will see that. So we should call the constructor of the parent object. And in this case, parent object is just object without any kind of meaning. But anyways, so if you call super, by the way, it gives you this kind of definition, it's okay as well. You can leave it like that. Or you can make it simpler. In Python, I think from 3.7, you can do this. You can just write it as super and then init, like that. So I see that the Rohit is also done. So yeah, just catch up with the code now. So here we will define then self. This will be the protected variable actually. If you want a private variable, then you need to have 2 lines here, 2 underscores, but we don't want it right now. Otherwise, but actually here we could have it. Yeah, so you can experiment it later. So you can have 2 lines here. This will be a private, and with 1 underscore it will be protected. You will see the difference later. So here we will define some value. It might be nice to give some default values as well. So we could have here x and y, like that. Also, yeah, so let's leave it as that. So then self and 2 underscores to make it as a private variable, and y, like that. X, y, like that. And now, if you look at the way how it works, so let's create some kind of dummy position. You can write it whatever you want. So this part is not, it's again, you primarily write this part. So this part is just to illustrate how it works. So here, let's see. So if we want 1, 2, so let's say we want x position as 1 and y position as 2. By the way, if you hard code any numeric values, it's always very important to add the keywords here, because otherwise the code will be unreadable. So now we have some dummy position created here. If I add a breakpoint and try to run it, let's see what happens. Yeah, so it works. It works. So this dummy position is working. But the interesting thing is that if I press here, and I don't have really access, especially PyCharm is ensuring that if I force it, I can get what is the value of x and what is the value of y. But basically, if I would try to modify it, I think the PyCharm will call that this is not allowed. So if I try to modify it here, if I want to say the x as 4 and try to run this again, there should be an error, hopefully. Okay, no error. Okay, So the Python itself do not like prohibit this, but basically you should not ever modify values that are either private or protected. Let's see, let's try again. Yeah, so there is at least this version of Python that I have is allowing me to just go through this, but normally you should never access it directly. So if you would like to access it directly, we could add something that we could access directly. So let's say self some, let's say public name, and we can set it as empty. And then here, if you code, it will actually give you that public name is available, but those other variables like the X and Y, they are not even visible here at all in the autocomplete because they should not be accessed from outside of the role. So here the public name we can easily change. So this will be, let's say, rocket position. And it works, but it's not allowed to change the X and Y positions directly like this. Like if you change this, this is not allowed. And by the way, the upper part here, this is not recommended. Because in this way, we have no control over what is stored in this variable. It can be anything stored there. Basically, sometimes we want to prohibit storing something that is breaking the code. So we should not use this kind of syntax. So I will drop this in the Jamboard quickly. And then we'll move on to the functional part here. So you see there are functions as well there. By the way, again, this part of the code is not necessary to make this work. So now let's move to the functional part. So the functional part is here. So we will have the set y, set x, and here we'll have the value or what was the x here, right? Self x like that. And then we will have another function called def get x. And here we will return the x value. And then we will have the same thing for y. In some languages, this part of the code is generated automatically, and you can override it. And in general, in Python, you can do the same. It's just that in the very beginning, it's very important to understand how it works, so that later, if you see something like that, you know why it is there. So this is the kind of basic backbone of our disposition to the object. We will rewrite it a little bit different a little bit later. But now let's use this one. So I will drop this in the Jamboard, slide number 3. And I will wait for you to catch up with this. I hope I don't have mistakes here. So is the position to the class ready? So this is then my question. And then we'll move on to the other parts. Oh, nice. I see that Rohit is already done. Let's wait for Christian as well. And by the way, if you have any questions or suggestions, you can write in the chat. We will rewrite this code in just in a second, a little bit different. So nice, you have a good speed. That's good. I don't hear your keyboard sounds, but it seems like you're good speed. So okay, this one is then ready. Oh, okay, so like that. By the way, PyCharm wants you to add 2 lines in between statements so that you would don't have this kind of marking under there. So let's keep experimenting. So the way how we want now to experiment is that I don't want you to write the code that I will write now, because this will be just experimental code. I want you to look carefully at the code and let me know what are the values there, okay? So let's see, we'll have position A, position to the x0, y0, then we have position B as 1, 1. Okay, let's add, no, well, we can stick it as it is. So we have position A, position B, then we have, then let's say position A is position B, then let's say then position B set x will be 2 and position B set y will be 2, and now let's print out the values. So the first one will be then position A get position x, and then the second line will be position B get x. So please type in the chat what do you think what will be the two values here, the line number 1, line number 2, without coding, hopefully, because if you just code like a monkey to do this, this is not optimal. We just want to look of what do you think here. Please type in the answer. So type in answer. So the answer should look something like this, like 9, 9. So if I type in this answer, this is definitely wrong, right? So please type in your answers. And if you will do this very slowly, then I will have suspicion that you are typewriting like in a monkey speed and not actually thinking about it. So you should just look at the code and give me the answer without trying to implement the code, please. Okay, there is another answer. So if you don't know what will be the answer at all, then type in minus. If do not know the answer, then type in minus. Okay, I have suspicion that you don't know the answer. Am I correct? Or you just not listening, or what's the problem? Hello. Okay, so I hope that the Rohit who gave us 2-2 did this in the head, not in trying to type this very fast. But so when Christian is giving me minus, so that's also fine. So that just illustrates a little bit more of the situation. So yeah, so let's return to this a little bit later. So so if we create an object like this, so let's create another object. Okay, I see in head, so that's good. That's good. So here this will be position C. Forget about all other things before. So let's just write this maybe. So let's write this together. So this will be not position C, but yeah, position C, whatever. So please write this code. So they are actually pointers, by the way. There is no really such thing as reference type. In all of the languages starting from C up till Python, JavaScript, whatever, you can get pointers. So they are just pointers to memory locations. I think we already talked about this when I was explaining you about the ways how to access lists, I think, if I'm not mistaken, in these kinds of tutorials already. So, but don't worry. So here, this is then the position C here. So let's play with it. So position C, set X value to something, let's say 3 or whatever. And then we can print out this value, position C get X, and position C get Y. And then we can write also exit here. So the exit will kill the program here. And if I run it now, you will see some result, hopefully. Yeah, so you see 3 and 0 here. So, and this is what is expected here. So please try to write this small dummy code down here. Later you can just select this and comment it out by using the control and kind of control. So you can use control plus this key to comment out stuff like that. So please write this part of the code, and then just let's play with the way how it works, because it seems like that Christiana did not get it immediately, but that's fine. So yeah, so is this code done? If you have any problems, so I see I guess 1+ from the rocket, but if you have any problems, then please let me know what kind of error do you have or what problem do you have. We should get to this point without errors and problems, okay? So I see rocket is plus. What about Christiana? And by the way how it works, if there is something not clear, then also please ask a question. Okay, so it works, so that's great. So what you can do, you can then start playing around with it. So what happens if you, let's say, give here 2, then what will change the output? So this will get us 2, right? Then we can, for example, print out this line and then change this a bit later. So let's change the Y to 3 now, and then print again just only position get Y. And in that way, basically we have only 2 types of operations. We have the kind of setting the values of the X and Y using these functions and getting the values. There's nothing very smart here, right? And we have this kind of one instance of the object, right? So is this far everything clear? Is everything clear this far? Plus, minus. If something is not clear, then type in what's not clear. So what I'm trying to show you is that you can define an instance of an object and then change some kind of internal properties using these functions, and it will be stored in that instance. So all of the memory is inside this object. So you should now understand few terms. So the position C, this is called an instance. So this is not any, this is just like a kind of, how you could say, produced, like, I don't know even how to then, like the produced set of code from the object or class, okay? So this is what we have, that part. So then the position 2D is not an instance. This is a class or like a template that you can create many times, many times. So this is not exactly like template, but very similar to template. So you can create many times these kinds of instances of objects. And these objects then will be called instances. So I know I'm confusing. So here we have the one which is position C, but we can have position D as well. And now, if we change something inside position C, like setting set X to 4, it will not change the position in the other instance. So if I print out get X from C, and if I print out get X from D, they will be two different outputs. Do you understand it so far? Do you understand this so far? Plus, minus. If minus, then please some question. So now I'm showing that if you instantiate from the class object the instances, then each instance have their own set of member variables, so their own things there. Yeah, so you're writing me the answer there, but yeah, so you're getting it. So that's great. So that's so far so good. So they're kind of like their own like set of information stored inside those small instances. So then the more difficult part becomes, and what should be noticed is that what if we want to set the like if the position C X, so to say, or like that, is actually now 4, but we want to copy the position, we want to copy position C X to position DX. So if we want to do something like this, it would if we would like to also do maybe something like this with the Y as well. So now the Y's are the same, but we could change it, of course. So like that. Then maybe somebody would think that the smart thing would be to use position D is equal position C, but this is something you should never do. Never ever do something like this. Because as soon as you do this, you're actually not copying anything, because you're just setting the same pointer, so the memory location of this position C to the position D, and now what you end up is that you have two kind of instances pointing to the same exact object instance here from the position C, and position D is lost in the black hole. Position D is not available at all. You cannot access it in no way now after this line, because you destroyed the pointer there. So let's ask them the question. So if this is not the way how to do this, then what do you think how to copy these data from one to another? So how then to copy data from position C to D? Do you have any ideas? Maybe you can type in what would be the correct way to do this. So this is definitely not correct way. You should never do this. So you can do this only with not complex types. Remember, very beginning we was talking about complex types. So this is complex type, this class instance. But you can do this only with and then there's the simple types, right? So let's see. So there is one option given. I like it, and I think that's one way that should be acceptable. So the Rocket is giving the idea that what we could do is use something like this set X, and then use position C and get X here, right? So we are getting simple data type X, which is integer, right? Not the complex data type as position, and giving this to the function where it's replacing it here, right? And we can do the same thing, of course, with the Y here, right? And in this way, we actually accomplish what we set out to do, to copy data from one instance to another instance without destroying the pointer, basically making program unusable. So is the data copying clear? or something not clear? So plus, minus. Let's see. What kind of feedback do you have? And meanwhile, I will copy this part of the code to the Jamboard so you can explore and think about this later if necessary. So I get that Rohit is getting this. What about Christiana? So if there is something not clear, it's okay. It's better to write the question so we can explain more times than later to be confused. Okay, so great. I hope that you're also getting with this. So this is good. So let's then do another thing. So far everything great. But the way how it's written now for the Pythonic syntax, this is not that beautiful. We can write it a little bit a kind of more beautiful way, and it will just make the code also easier to access. So now we're going to change it in more Pythonic way to do the properties. So I have a question in the chat, so that's great. So the question is, does the position with the underscores to the copying directly from one to other, so if we would actually execute this line like that, would it work? It would work if there would not be enabled some kind of artificial like limitations to the Python, because you can see now this is highlighted. And so let me show you actually. So the PyCharm is showing me that if I scroll over this, it shows me that the unresolved attribute of X here. So that basically means that you don't want me to access that attribute because that's marked as private. If there would not be those two underscores, then it would not complain about this. But in general, you should never do this. It's just completely wrong way how to do the code and would defeat the purpose. So yeah, so let me just help you to understand the purpose. So first of all, let's see. So we have setting y position. So if this is a function, then we can use a very nice properties of the functions. For example, one is that if let's say the y value, so we can actually write it in a very Pythonic way. So the very Pythonic way would be like that. So if y is larger or equal than 0 and smaller than scene height, only then we set this variable. If we have something else there, we will not set that variable at all. And this is a very nice feature because then we don't need anymore to check anything, right? So we can add it in this way. Again, as I said, this is a very Pythonic way to write this, because I will just in a second write how you can write it the other way, like in other languages as well. So in other languages, you will write this in this way. So you write this as and you write here as x like that. And you see that Python is actually saying that this is not optimal way how to write in PyCharm, but you could do this in this way. If this makes this syntax more clearer, please write it in that way. So, but you can write it also in that way. So you see the value of getters and setters. If we just copy values from one another directly, we don't have this access to correct the values and do not allow to store something that is inappropriate, right? But now we have this access, and there will be also some design patterns that will be very useful in this same manner. So let me check, are the code checks ready? Great. So let's then change the last thing regards to these encapsulation tutorial that we are having now. So in Python, usually you don't want actually to write these kind of get and set functions. What instead you do is you use the @ symbol here and then use the property. So this kind of syntax, I will explain it maybe in a few sessions down the road, but this is nothing magical. There is very simple way what is actually doing. This is just wrapping function around function. And now here we will use just the x here. So this will be the, sorry, I accidentally used the property on the wrong function. So you should add property to the get function and then leave just as x like that. I would also advise you to make this as a first function here. Just let's use the get functions as the first functions here. So this previously it was get y, and now it's just y. Now it's just x, get x, now it's just x. And then we will also do the same strange thing to the setter. So, but now it will be x.setter. Very important to see that there is an x there, not property anymore. And here we then, I think actually even, do we need to change it, but we could change it, so like that. So the x like that. By the way, this is also not optimal that we are using the same x as here, x. This will be just making very confusing everything. So let's change this to value, or just val. So this will be value, right? So let's add value like that. Otherwise, the code is really confusing. So we have this part also up here, because the x now is a property name. Would be nice to change to val x and val y, and then also change here. In Python, it's really nasty if you somehow mix up that there is some kind of function name, class name, or something like that with the same name as variable name. Like, for example, in Python, you should never ever use any variable called id, because id in Python means the pointer, so it will just make your code work when it should not be working. So we will use this part, and then we can change also the y part. So again, the same way, add property, then y, like that, and then for the at y, now not x, right, setter, and here this should be y, and there will be value, val, and hopefully now it will work. So I will scroll a little bit down, maybe squeeze it together a little bit, because I want to check if it works so I didn't screw it up. So let's see. So position, so let's see, so position. Now we don't have any more those gets, so what we can do is just use x like that, position c, y, and we can do also position c, so x would be something like 4. So it seems like that it's working. Let me run it. Oh no, something not right. Ah, okay, got it. So it doesn't like that my variable names now are different here. So we could add it also here, val. Okay, now run it again. Yeah, it works. So I will drop this in Jamboard as well, so you can catch up with this. But I will also explain what it's doing. So just a second. So I drop this into the Jamboard slide number 4. So this is the way how to write the classes with using getters and setters in a nice way for the Python. So this was before set x, this was before get y, and this was before set y. So for the coding part of the class, it makes a little bit more code, but then when you use it, it makes a much more nicer usage. So let me wait for you to catch up with this part. So are the properties ready? Properties ready, plus minus. If there is some interesting bugs, let me know. Okay, I see 1 plus, so that's great. Yeah, I believe that Rohit also should be able to do this. So now, if we have the position D, C here, and position D here, right? Now we can write much nicer the copying of data, right? We still cannot never write this way, like position C is position D. This is wrong. This is a complex types. You cannot copy complex types in this way. So what you can do instead is then to do the, if you want position dx to be the same as position dc, now we can write in this manner, as if there would be a public member variable, but what instead is actually happening is that it's pretending to be public variable. It's actually getters and setters there, and they are called properties. And the same way how this code works is also in all sorts of modern languages like Java, like in C# and other languages as well, where you have the properties like behaving, like pretending to be these public variables. So that's great. So far we are done with this. So let's make some small changes below here. So first of all, position of the rocket will not be anymore this coordinate of like just like list here, but it will be position 2D, and by default we want it to be somewhere in the middle, let's say. So let's say, so for the middle, to position the rocket in the middle, what we should do is integer. So because if we divide something, well, it will be then decimal number probably. So let's see, scene width divided by 2, so this will be the center. Maybe we should also -1. It might be more in the center, it might not be. So then the same for the y, just using the width, just using the height. So, and then you just need to change the code below in order to make this to work with this class, okay? So I will drop this also in the Jamboard. So this will be your first homework. We will now go back to the UML a little bit, and for the first homework, just let me double check. So do you think that you can make a game work with position 2D instead of the way how it was before, using just the list of integers? So plus minus. So do you think you can do this? If you cannot do this, if you write that you cannot do this for some reason, you didn't understand how it worked before when I showed you the examples, then let me know in the chat and I will show you how to do this. But that would not be optimal, but it would be not nice, much better if you can do this at home yourself, because I just showed you how to change the and get the values out and in from that position. So I see the rocket can do this. Let's see what Christiana thinks. I hope that you can also do this. Even if you're not sure, please try then. So what do you think? Let's wait for an answer. If you absolutely do not know how to do this, then let me know, then I will show you. Okay, so yeah, so you're accepting the challenge, so that's great. So this will be the first homework to change the game so that it would work through this position rocket, because now if I will run the code, it will crash here because this is not list anymore, this is an object. The instance of object, it will crash also here. So maybe you should also then change this part, because we did some interesting things up there. So this will be first thing. So then next thing is that I want to look more on the UMLs here. So just for you to start thinking about some of the things, because we will not be able to do all of those at once. So first of all, this first thing is called encapsulation. Encapsulation. Then the next part we will gonna look in the object-oriented programming is inheritance, and it will be also a little bit combined with polymorphism. You will see that. So here, let's see. So we'll have some base class here for these objects in the game. So we will call the objects in the game as elements. Element. By the way, I should have used the other type of with the functions. So element and elements. By the way, I will also copy this part from this UML as well, because I want you to show this. What I mean by that. Oh man, how to copy it? Copy, paste here. Right, now it's working. So this will be the element of all sorts of elements. The rocket will also be element, right? So then here in this element, we will have the position. Position will be the type of position 2D. And basically what it means is that we will have the so composition, so UML composition of that position 2D inside that UML diagram. So the way how to write this is, if we go here, there's different kind of arrows and stuff here. So one of this is composition and aggregation. So composition looks something like that. We would add one side here, and the other side, it actually doesn't matter, but somewhere here. And also maybe we should make that this line is something like that. So if I click on the line here, I can change the styles and stuff like that. So that's not super important. It's just that the data that this is called composition. So it means that this kind of element will now use this other object type. So this is complex type consisting of other complex types. This is what is happening in programming all the time. We are doing all sorts of things like these. So this is composition of that type. So we will use it here. Then what else? There should be something else as well. So first of all, this should be minus, of course. Oops, minus, and now let's see. So we will also have duplicate. We will also have here the character. So just this will be a string. So this will be the kind of what is the spaceship looks like. So for example, by default, it could look like, let me see, spaceship like that. So by default, it could look like that, but it could be something else as well. Okay. So that we have. What else we could do is, let's see. So we have positions. Yeah, those things. Let me check how the code structure looks like. Yeah, so we could actually use function draw. So we would like to draw this somewhere and give the scene inside this function. So this could be like your base kind of object. So don't worry about this. We will look at this more details next week. It's just like starting to give you intro about these things. You should maybe check about them and read them a little bit more. So now let's see. So we'll add the other element here. Let's see. So there could be movable element, and for movable elements, we might want to also have not only position, but also direction. So let me see. So don't worry that you cannot maybe catch up with this because we need to hurry up a little bit. I will give all the details also in the Jamboard after the session. So direction here. This will be the kind of direction on which it's moving, right? And we don't need any more draw because draw is something that's already included. Instead, what we could do maybe is what we could be doing, like check collision maybe. Let me think. Yeah, so check collision, and this could return maybe Boolean if there is a collision or not collision, right? Maybe. So this part, and we also might want to have speed. So speed, and this should be then maybe floating type of variable. So we have this, and then the next thing we want to try out is something called inheritance. So let me find where is the arrow that represents this. So this one extends. So how it works then is that it says that this class, so the bottom part class movable element contains all of the features from the above class. Let me draw it like that. Contains all of the features from above class and adds additionally these features. By the way, we then actually don't need to have the position written here, and also even the character written here, because they will be actually included in this class by default. So because this is just an extension of the other class. So now I'm saving it. So this will be a movable element, and we can also produce some kind of immovable element or static element. And in this case, this might be just a wall. So wall, and this again could be the same type of relationship between objects. By the way, hopefully you're starting getting that what I'm drawing here is just like a kind of a visual representation of the code. And in your code, you can write all of these things just in like a programming way, right? But this is just the way visually to represent what's happening. So don't worry if you don't catch up with this. I will share this a little bit later. You can then try to replicate these diagrams. So first of all, this thing. So the wall, there is what else here? Maybe we want to have also, but if it's a static, maybe you don't need to check collision. What else we could do here is maybe we could just define that the wall will look in some particular manner. Maybe this will look as the, let's see, coastal, no, yeah, I don't know, like something like that maybe, whatever. So basically you have two classes that are inherited from the one, like this master class or the super class or the parent class, and they are all using different kind of data. Maybe we should also try to arrange this a little bit nicer manner, so that there is no overlaps between these lines here, like that. And now I will quickly, just like in a few minutes, maybe write down how it looks like in the code. And then I would just want you to like carefully copy that code, think about it, try to understand it a little bit better. And next time you're going to work with this more. This is not going to be like a big part of the homework, because the homework's main part is where you just use the position 2D. But if you want to start implementing all of these things, it'd be nice to do that as well. Because, for example, the movable element, that's basically the rocket. You can have either the subclass of that as a rocket, or use just movable element as your rocket. It's also possible. So let me just quickly add this to the Jamboard and then implement this in the code. So you would have some kind of just like intro in what it means actually. So now let me add it here in the Jamboard. So this will be the part of inheritance. This is a very small part of that actually. Inheritance. And in the code, it would look something like the following. So we have the position 2D here. Let me share the code. Position 2D is something we already have. Then what we want also is the element. So class. By the way, now I'm not going to write all of the getter setters. You should. That could be also a homework to write the getter setters for all of those things. But let's stick with the positions basically. Element. So the element is the base object here. Then the def init. This is called constructor. Constructor. Every time we construct a new instance, this will be get called. So super, like that. Then self, as in the description, we have the position. Actually, I think you should do that in homework. You should make getter setters for these elements also here. It will just let me understand how well you understand that. So position 2D something. So this will be just some kind of random position now. Position. This is one. Then the other thing will be the character, right? Character. So char. So this will be something that's not really that important what it is. It just should be emoji, so it would be the same size because you're making emoji game, right? So then def draw. So this will be the draw function. And now, so okay, we could actually do something dummy here. Solve character. So we just draw the character here without any smart things here. So this is to do for later. But what you should do at home is add getter setters. Add getters and setters to position and character. And by the way, character is something actually you don't need getter setters because it will not change during the game. Only position will change. And actually, you just need getter. You don't even need setter, by the way. Add getter to self position. Because I will show you later, but basically you don't need setter for this kind of task at all here. So you need to add that one. So this will be a to-do for the homework. To do. So add the getter of self position. So then the next more interesting part comes. So class, let's say wall now. And the wall is inherited from element, and we type element here. So now, at this moment, when we will construct any kind of instance with a wall, it will contain all of these code parts of these here. So we can even copy this part just here just to make it quicker. And here we will override this part with this kind of character, whatever. So this is one. And then the last is the movable element. Movable element. And this is again inherited from element. Movable element, what it contains, we could change this part as well. It's not that important now, but what it contains is the direction and speed. So then no worries, I will drop this code also in the Jamboard so you can catch up later. So speed will be something like 0.5, and then direction. Direction will be again the position 2D. By the way, it could be possible to join position and direction just in one vector. It's just that it'll be maybe easier to understand. So that part, and then def check collision, and we will pass scene here inside. Scene instance. It would not be actually good to use the same variable name as down below. And then let's say print do something here, do something. And here, what basically we need getter and setter for speed, I guess, to do getter and setter for speed. So these are properties. Basically, you should make a in the way using properties, right? Property, and then property, and then you need only. Again, you need only getter for the direction, because direction again is complex type. For complex types, you often don't need anymore the setters. Getter for direction, basically for direction. So that's again homework here. So you should try to catch up with this code later and try to finish the homeworks of making these classes a little bit more decorated and making the position rocket work. And also, I will add some small dummy examples. So dummy wall will be the wall of this, and dummy movable element, movable will be movable element. So, and the interesting thing here is that both of these can directly call draw here. And this is something that we inherited from the base class, and that's really nice thing. And if you will run this, you will see that it will draw a different kind of character depending on the class, just because it's overriding it later. So this is one small intro to the object-oriented programming. We will have more the next time. I will drop carefully this part of the code to the Jamboard so you can copy it. So, and your homework will be to finish these getter setters where it's missing, and also to make sure that game works with the position rocket. And if you want to make a step forward, you could maybe try to use those upper element classes, but if you don't, it's fine. We will work with that next time. Okay, so hope it was informative, interesting, and hope you're starting getting along with this. I will send the link for the homeworks, and we'll meet next week, same time. Okay? Bye-bye.